Hello, in this lecture we will answer on two questions. In the first question we will find out the diameter of this orange circle, and in the second question we will find out the value of the size of this angle theta. So we'll start with the first question. In the drawing we have three semicircles, and the biggest semicircle contains two small semicircles and one orange circle, and we want to find out the diameter of this orange circle. Okay, so first of all we will define the center of the orange circle as point C. And we will define the radius of this circle, the radius of the orange circle, as R. So I'll write it down. R is the radius of the orange circle. Okay, and we will define the center of this semicircle as X. We will define the center of the biggest semicircle, this semicircle, as Y, and we will define the center of this semicircle as Z. We know that the diameter of this semicircle is equal to 10 units, therefore its radius will be equal to 5 units. The diameter of the biggest semicircle is equal to 10 plus 20, that is to say it is equal to 30 units, therefore its radius will be equal to half of it, that is to say 30 over 2 is 15, so the diameter of this, the biggest semicircle is 15, and the radius of the biggest semicircle is 15, and the radius of this semicircle is equal to 20 over 2, that is to say it equals to 10 units. And we want to find out the diameter of this orange circle. So we'll join point C and X together with a straight line. We'll join all the centers of the semicircles with the center of this orange circle that is located at this point, point C. And in order to find out the value of the line segments in the drawing, I will present to you two new terms. Actually, when two circles are tangent to each other, they can be tangent to each other in two different ways. The first type of tangency is the external lunge, in this drawing we have two circles that are touching each other externally at this point. This is the point of tendency, and we know that the center of the small circle, this circle is at point M, and its radius is equal to small r, while the center of the big circle, this circle is at point O, and its radius is equal to capital R. In this case, the distance OM between the centers of the two circles will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this small circle, that is small r, plus the radius of the big circle, that is capital R. So in conclusion, the distance between the centers of those two circles will be equal to capital R plus R, and whenever two circles are touching each other externally, like in this drawing, then the distance between the centers of the two circles will be equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r. And we also have a second type of tendency between two circles. When the two circles touching each other internally, like in this drawing, those two circles are touching each other internally at this point. This is the point of tendency between the two circles. Then it is defined as the internal lunge. Okay? And the distance between the centers of the two circles, that is to say, the length of line segment MO, will be equal to the sum of the difference between the lengths of their radii. Okay, in this case, it will be equal to capital R, one small r. So whenever two circles are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r, or M equals to capital R minus small r. Okay, so we will return to our original drawing, and we will find out the length of line segment XC. What is the length of line segment XC? Actually, we know that X is the center of the smallest semicircle. This semicircle with radius 5. C is the center of the smallest semicircle with radius R. And those two circle and semicircle have an external lunge between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency between them, and therefore the distance between their centers, that is to say, the length of line segment CX, will be equal to the sum of the lengths of their radii. In this case, it will be equal to the radius of the orange circle, that is R, according to our definition, plus the radius of this small circle, semicircle, that is 5. So, in conclusion, we found out that the length of line segment XC equals to R plus 5. Likewise, we will find out the length of line segment CY. C is the center of the orange circle, this circle with radius R. Y is the center of the biggest semicircle with radius 15. The orange circle and the biggest semicircle have an internal notch between them at this point, that is to say they are touching each other internally at this point. This is the point of tendency. And whenever you have two circles that are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest circle, that is 15, minus the radius of the orange circle, that is r. So in conclusion, we found out that Cy equals to 15 minus r. Okay, Cy equals to 15 minus r. Likewise, we will find out the value of line segment CZ. C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. And those two, circle and semicircle, have an external notch between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency. And whenever you have two circles that have an internal notch between them, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is 10, plus the radius of the orange circle, that is r. That is to say, we found out that Cz equals to r 10 plus r. Okay, Cz equals to 10 plus r. Likewise, we find out the value of line segment xy. Here, x is the center of the smallest semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. And those two semicircles have an internal notch between them at this point. That is to say, they are touching each other internally at this point. Whenever you have two circles or semicircles that are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the smallest semicircle, that is 5, and 15 minus 5 is 10. So we found out that xy equals to 10 units. Xy equals to 10 units. And likewise, we find out the value of line segment xz. Again, x is the center of this semicircle with radius 5. Z is the center of this semicircle with radius 10. And those two semicircles have an external notch between them at this point, point P. Therefore, the distance between their radii will be equal to the sum of the lengths uh, the distance between their centers will be equal to the sum of the lengths of the radii. That is to say, it will be equal to the radius of the smallest circle, that is 5 units, plus the radius of this circle, that is 10 units. So 5 plus 10 is 15. So xz equals to 15 units. Okay. Okay. In the next step, I present to you a new law, and we will implement the new law in our drawing. That is actually the law of cosines. The law of cosine is true in any triangle. So if we have triangle ABC, this could be any triangle. And we know that side AB of triangle ABC equals to A units in its length, side BC equals to B units in its length, and side AC equals to C units in its length. Then, according to the law of cosines, we will get that, and we also know that the angle between side AB and side BC is theta. So according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay. And actually, the Pythagorean theorem is a special case of the law of cosines. When angle theta equals to 90 degrees, when angle theta equals to 90 degrees, then we have a right triangle. And in any right triangle, we know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And in our case, we get that cosine theta equals cosine 90 degrees equals to 0. Therefore, 2ab times 0 will be still 0. And therefore, we get the Pythagorean theorem that states that c squared equals to a squared plus b squared. That is to say, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? So we'll implement the law of cosines in our triangle CXY. So I'll copy triangle CXY. in a new page and we will implement the law of cosines in this triangle. So this is triangle CXY that I copied from the original drawing. This angle is angle theta. And we have already found out that XC is equal to R plus 5. We found out that XY is equal to 10 units. And we already found out that CY equals to 15 minus R. So, according to the law of cosines, if we implement it on the right on triangle CXY, this will be equation number 1. We will get that CY squared equals to CX squared plus XY squared plus 2 times CX XY times cosine theta. Okay. And we have already know that CY equals to 15 minus R, CX equals to R plus 5, and XY equals to 10, so we substitute CY, CX and XY by those values that I mentioned, and we get that according to equation number 1, CY is 15 minus R, so CY squared is 15 minus R squared, and it is equal to CX squared. CX is 10, so CX squared is 10 squared. 10 squared is 100 plus X. So this is XY squared plus CX squared. CX is R plus 5, so CX squared will be equal to R plus 5 squared. So CX squared equals to R plus 5 squared, XY squared equals to 100, minus 2 times cx is r plus 5 times xy is 10 times cosine theta. So here we'll open the brackets on both sides of equation number 1 and we get that 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15 times r is minus 30 times r, and it is equal to 100 plus r plus 5 squared equals to r squared plus 5 squared, that is 25, plus 2 times r times 5 is plus 10r, minus 2 times 10 is minus 20, times r plus 5 times cosine theta. So here we have r squared on both sides of equation number 1, so r squared will get cancelled. What is left from equation number 1 after we cancelled r squared? What is left? It is actually in this side. What is left is that in this side we left with 225 minus 30r. And on the other side we have 100 plus 25 is 125 plus 10r minus 20 times r plus 5 times cosine theta. So here we will subtract 125 from this equation, equation number 1, and we will get that 225 minus 125 is 100, and we will subtract 10 out from this equation, equation number 1, and we get that minus 30r minus 10r is minus 40r, and it is equal to minus minus 20 minus 20 r plus 5 times cosine theta. Okay, here we multiply equation number 1 by minus 1, and we get that according to equation number 1, minus 40r times minus 1 is 40r, 100 minus 1 is minus 100, and it is equal to minus 20 times minus 1 is plus 20 times r plus 5 times cosine So the other side of equation number 1, we have 20 times r plus 5 times cosine theta. Here we will divide equation number 1 by 20 times r plus 5, and we will get that according to equation number 1, cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we will divide both the numerator and the denominator of this side of equation number 1 by 20, and we will get that 40r over 20 is 2r, minus 100 over 20 is minus 5, and in the denominator we have 20 over 20 is 1, so in the denominator what is left is actually r plus 5. So actually we found out that according to equation number 1, tangent theta equals to 2r minus 5 over r plus 5. Okay? In the next step, we'll do the same process on triangle CXZ. So we'll copy triangle CXZ in this new page, and we will implement the law of cosines in triangle CXZ. Okay. So this is triangle CXZ that I copied from the original drawing. We have already know that CX equals to r plus 5. And XZ equals to 15 units. And CZ equals to 10 plus r. So we will implement the law of cosines in triangle CXZ. So this will be equation number 2. According to equation number 2, we will get that CZ square this is again theta, of course. CZ square equals to CX square plus XZ square minus 2 times CX times XZ times cosine theta CZ. Actually, CZ is 10 plus r, therefore CZ will be equal to 10 plus r square. And it is equal to CX square. CX is r plus 5, so CX square is r plus 5 square plus xz squared. Xz is 15, so xz squared will be equal to 15 squared, that is 225, minus 2 times cx, that is r plus 5, times xz, that is 15, times cosine theta. Here we will open the brackets on both sides of equation number 2, and we get that according to equation number 2, 10 plus r squared equals to 10 squared, that is 100, plus r squared, plus 2 times 10r is 20r, and it is equal to r plus 5 squared, that is r squared, plus 5 squared, that is 25, plus 2 times r plus 5 is plus 10r. Okay, so r plus 5 squared equals to r squared plus 5 squared, that is 25, plus 2 times r times 5, that is 10r, plus 225, minus 2 times 15 is minus 30, times r plus 5 times cosine theta. Here we have r squared on both sides of the equation, so r squared will get cancelled. So after we cancel r squared, we have in this side of the equation 100 plus 20r, and on the other side of the equation we have 225 plus 25 is 250, and so it is 250 plus 10r minus 30 times r plus 5 times cosine theta. Here we subtract 250 from this equation, equation number 2. So 100 minus 250 is minus 150. And we will also subtract 10r from this equation, equation number 2. And we will get that 20r minus 10r is 10r. And it is equal to minus 30 r plus 5 times cosine theta. So here we multiply equation number 2 by minus 1. And we get that according to equation number 2, minus 150 times minus 1 is 150. 10r times minus 1, 10r minus 10r times minus 1 is equal to minus 10r, and it is equal to minus 30 times minus 1 is plus 30, so in this side of the equation we will have 30 times r plus 5 times cosine theta. Here we will divide the equation number 2 by 30 times r plus 5, and we will get that according to equation number 2, cosine theta is equal to 150 minus 10r over 30 times r plus 5. So here we divide both the numerator and the denominator on this side of equation number 2 by 10, and we get that 150 minus 150 over 10 is 15, minus 10r over 10 is minus r, over 30 over 10 is 3. So in conclusion, we found out that according to equation number 2, cosine theta equals to 15 minus r over 3 times r plus 5, while according to equation number 1, we have already found out that cosine theta is equal to 2r minus 5 over r plus 5. In the next step, we will create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So equation number 3 states that cosine theta according to equation number 1, that is actually 2r minus 5 over r plus 5, must be equal to cosine theta according to equation number 2, that is actually 15 minus r over 3 times r plus 5. Okay. Here we will multiply equation, first of all, we will multiply equation number 2 by r plus 5, so actually we have r plus 5 on both sides of the equation, so r plus 5 will get cancelled. The next step we will multiply equation number 3 by 3, and we get it according to equation number 3, 3 times 2r minus 5 equals to 15 minus r. We will open the bracket on this side of equation number 2, and we will get that according to equation number 2, 3 times 2r, 3 times 2r is 6r, 3 times minus 15 is minus 15, and it is equal to 15 minus r. Here we will add r to this equation, equation number 3, and we will also add 15 to equation number 3, and we will get that according to equation number 3, 6r plus r is 7r, 15 plus 15 is 30. So according to equation number 3, 7r equals to 30. We will divide equation number 3 by 7, and we get that according to equation number 3, r equals to 30 over 7 units, but we want to find out the diameter of the open circle. The diameter is twice as large as the radius, so the diameter of the orange circle will be equal to 2 times the radius, 2r. 2r is 2 times, r is 30 over 7. 2 times 30 over 7. 2 times 30 over 7 is 60 over 7 units. Okay. So we actually found out the diameter of the orange circle will be equal to either 60 over 7 units, or in terms of numbers, it is equal to 8.5714 units. I'll repeat again, the diameter of the orange circle will be equal to either 60 over 7 units, or in terms of numbers, it will be equal to 8.5714 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the diameter of this orange circle. The orange circle is inside the semicircle, and inside the semicircle we have also this small semicircle with radius 5, this small semicircle with radius 10, and we want to find out the diameter of this circle. Okay. Actually, we join together all the centers of the semicircles with the semicircle, with the center of the semicircle, and in order to find out the length of the line segments that in the drawing, I presented to you 2 new terms. The first new term is the internal lunge. When 2 circles are touching each other, the first term is the external lunge. When 2 circles are touching each other externally, then it is defined as external lunge, and the distance between the centers will be equal to the sum of the lengths of the radii. In this case, it will be equal to capital R plus small r. And we have also a second type of tangency, when 2 circles touching each other internally, then it is defined as internal lunge, and in this case the distance between the centers will be equal to the difference between the lengths of the radii. In this case, it will be equal to capital R minus small r. And we found out the sizes of the line segments here according to the 2 new laws that I showed you. Here, Cx, we define the radius of the orange circle as r, and the center is at point C. So Cx, we have here external lunge between 2 circles at this point. Therefore, the distance between the centers will be equal to the sum of the lengths of the radii. In this case, it will be equal to small r plus 5, r plus 5. Likewise, we found out the value of line segment CY, and here Actually, those two circle and semicircle have an internal notch between them at this point. That is to say, they are touching each other internally in this point, and then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to 15 minus r. Likewise, we found out the value of line segment CZ. Here we have external notch between the oval circle and this semicircle at this point. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to r plus 10. So we found out that CZ equals to r plus 10. Likewise, we found out the value of line segment XY. Here we have internal notch between the two semicircles at this point. Therefore, the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to 15 minus 5, that is 10 units. Okay, likewise we found out the value of line segment XZ. Here, the two semicircles have an external notch between them at point P. That is to say, they are touching each other externally at point P. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. The radius of this semicircle is 5, the radius of this semicircle is 10, so in total the distance between the radii will be equal to 10 plus 5, that is 15. Then I presented to you the law of cosines in any triangle. C square will be equal to a square plus b square minus 2 times ab times cosine theta. This the Pythagoras theorem is a special case of the law of cosines. When theta is equal to 90 degrees, then cosine theta is 0, and then we will get the Pythagoras theorem that c square equals to a square plus b square. So I copied triangle CXY in a new page, and we implemented the law of cosines in the triangle CXY. According to the law of cosines, cy square will be equal to cx square plus xy square minus 2 times cx times xy times cosine theta. Cy square is 15 plus 15, cy square is 15 minus r square, that is equal to cx square is r plus 5 square plus xy square is 100 minus 2 times r plus 5 times 10 cosine theta. We open the brackets here and we got that 15 minus r square equals to 15 squared, that is 225, plus r square minus 2 times 15 times r, that is minus 30r. And it is equal to 100 plus r plus 5 square equals to r square plus 5 square, that's 25, plus 2 times r times 5, that is 10r. Minus 2 times minus 2 times 10 is minus 20, so this expression equals to minus 20 times r plus 5 times cosine theta. And we have r square on both sides of the equation, so r square will get cancelled. And we left with 225 minus 30r equals to 25 plus 100 is 125 plus 10r minus 20 times r plus 5 times cosine theta. Here is subtracted 125 from this equation number 1, and we got that 225 minus 125 is 100. We also subtracted 10 from this equation number 1, and we found out that 30r minus 30r minus 10r equals to minus 40r, and it is equal to minus 20r plus 5 times cosine theta. Here we divided equation number 1 by, we multiplied equation number 1 by minus 1, and we got that 40r minus 100 equals to 20 times r plus 5 times cosine theta. Here we divided equation number 1 by cosine theta. We divided equation number 1 by 20 times r plus 5, and we got that according to equation number 1, cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we divided both the numerator and the denominator on this side of equation number 1 by 20, and we got that 40r over 20 is 2r, minus 100 over 20 is minus 5, 20 over 20 is 1. So in conclusion, we found out that cosine theta according to equation number 1 equals to 2r minus 5 over r plus 5. Okay. Then we implemented the law of cosines in triangle CXZ. According to the law of cosines in triangle CXZ, CZ square equals to CX square plus XZ square minus 2 times CX times XZ times cosine theta. Okay? And CZ square is 10 plus r square, that equals to cx squared, this is r plus 5 square, plus xc square. Xc square is 15 squared, that is 225, minus 2 times cx is r plus 5, and xz is 15. So here we open the brackets on both sides of equation number 2, and we got that 10 plus r square equals to 10 squared, that is 100, plus r square, plus 2 times 2, 10 times r, that is 20r. And it is equal to r plus 5 square. R plus 5 square equals to r square plus 5 square, that is 25, plus 2 times r times 5, that is 10r, plus 225 minus 30 times r plus 5. So here we have r square on both sides of the equation, so r square will get cancelled. And then we left with 100 plus 20r equals to 250 plus 10r minus 30 times r plus 5 plus cosine theta. And then we subtracted 150 from this equation number 2, and we got that 150, 100 minus 150 is minus 150, and then we subtracted 10r from this equation number 1, and we got that 10r, 20r minus 10r is 10r. Then we multiplied the equation number 2 by minus 1, and we got that 150 minus 10r equals to 30 times r plus 5 times cosine theta. We divided the equation number 2 by 30 times r plus 5, and we got the volume to equation number 2, cosine theta. Cosine theta equals to 150 minus 10r over 30. We divided both the numerator and the denominator of this end of equation number 2 by 10, and we got that 150 over 10 is 15, minus 10r over 10 is minus r, and it's equal to in conclusion, we found out that cosine theta equals to 15, according to equation number 2, equals to 15 minus r over 3 plus r plus 5. Then, and according to equation number 2, cosine theta equals to 2r minus 5 over r plus 5. Then we created the equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So cosine theta according to equation number 1 is 2r minus 5 over r plus 5, and it must be equal to cosine theta according to equation number 2, that is 15 minus r over 3 times r plus 5. We multiplied equation number 1 by r plus 5, so r plus 5 will get cancelled in the denominator. Then we multiplied the equation number 3 by 3, and we got that 3 times 2r minus 5 equals to we multiplied the equation number 3 by 3, we got that 3 times 2r minus 5 equals to 15 minus r. Here we open the brackets, and we got that 3 times 2r equals to 6r, and 3 times minus 5 equals to minus 15. So in conclusion, we found out that according to equation number 3, 6r minus 15 equals to 15 minus r. Then we added to this equation number 3r, and we also added 15, and we got that 6r plus r is 7r, and 15 times 15 is 30. So in conclusion, we found out that 7r equals to 30. We divided equation number 3 by 7, and we got r, the radius of the orange circle, equals to 30 over 7, and the diameter of the orange circle is twice as large as the radius, so it is 2r. 2r is 2 times 30 over 7. That is actually equals to 60 over 7. So the diameter of the orange circle equals to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. We finished with the first question. In the next step, I present to you the second question. In the drawing, we have a quarter circle. Inside this quarter circle, we have square ABCD, and we also have here angle AMB that is equal to 90 degrees, it is right angle, and we also have angle BQC that is equal to theta, and we want to find out the size of this angle, angle theta. So in order to find out the size of angle theta, we made a construction. We will make a construction. We will extend MA, and we will also extend line segment QO until they intersect with each other. And we will define the intersection point as point N. In the next step, we will complete the quarter circle to a semicircle. So this is the semicircle that we created from the quarter circle. Inside this semicircle we have peripheral angle NMQ that is equal to 90 degrees, and we also have rule number 1 that is related to peripheral angles that are equal to 90 degrees. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. I will read rule number 1 again. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So we have here peripheral angle NMQ that is equal to 90 degrees, therefore it must rest on the diameter. Peripheral angle NMQ rests on NQ, therefore according to rule number 1, NQ is the diameter of the semicircle. Okay, according to rule number 1, line segment NQ is the diameter of the semicircle. Okay, and we have here, this is a quarter circle, therefore OQ must be equal to the radius of the quarter circle. So OQ is the radius of the quarter circle, of the semicircle also. OQ, we define the radius as capital R, so OQ is the radius of the semicircle and the quarter circle that is equal to capital R, and the diameter NQ is twice as large as the radius. That is to say it will be equal to 2R. And what is the value of line segment NO? From the drawing it is very easy to see that NO equals to NQ minus here NO equals to NQ minus OQ. So NO equals to NQ, that is 2R, minus QO, that is R. 2R minus R equals to R. So from that NO equals to R, and OQ is also equals to R. This is the diameter of the circle and the semicircle also, or the diameter of the quarter circle and the semicircle also. In the next step, we will focus on the right triangle, triangle NMQ. In the right triangle, triangle NMQ, the sum of the angles must be equal to 180 degrees. So which angle we have here? We have 90 degrees. We have also angle theta. We have also the missing angle is angle MNQ. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We subtract 90 degrees from this equation, and we get that theta plus angle MNQ is equal to 180 degrees minus 90 degrees. It is 90 degrees. We subtract angle theta from this equation, and we get that angle MNQ, the missing angle, is equal to 90 degrees minus theta. Okay, we know that the missing angle NMQ equals to 90 degrees minus theta. So we can write here that this angle equals to MNQ equals to 90 degrees minus theta. And we also know that the sum of the all the four angles inside the square are right angles. So in square ABC all the angles are equal to 90 degrees. So we can draw here four right angles. And we also know that we already found out that NQ is the diameter of the semicircle and the quarter circle. Therefore, NQ is a diameter, it must be a straight line. NQ is a diameter, it must be a straight line, so I write it down. NQ must be a straight line. And Q must be a straight line. And we have also rule number 2 that is related to a straight line. According to rule number 2, the sum of the angles on one side of a straight line the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that NQ is a straight line. So if we focus on the upper side, of the straight line NQ at point O, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point O, which angles we have at the upper side of NQ, at this side of NQ at point O, we have here 90 degrees, and we have also here angle AON. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 2. So repeat again. On the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees according to rule number 2. Therefore, which angles we have at point O, at the upper side of NQ we have 90 degrees plus angle AON. In total, the sum of those two angles must be equal to 180 degrees. We subtract 90 degrees from this equation, and we get that angle AON is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle is a right angle, it is equal to 90 degrees. Likewise, if we focus on the upper side of the straight line NQ at point C, then the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of NQ at point C? We have here one angle that is equal to 90 degrees plus angle BCQ. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I repeat again. At the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees. So according to rule number 2. So at point C, at the upper side of NQ, we have 90 degrees plus angle BCQ. In total, they must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we get that angle BCQ, the missing angle, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So this angle is equal to 90 degrees. We'll continue to focus on the right triangle BCQ. In the right triangle BCQ, we know that the sum of the angles must be equal to 180 degrees. So which angles we have at the right, inside the right triangle BCQ, we have one angle that is 90 degrees. We have also another angle that is theta, and we also have angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. Here we subtract 90 degrees from this equation, and we get that theta plus angle OBQ equals to 180 degrees minus 90 degrees, it is 90 degrees. We will subtract theta from this equation, and we get that angle OBQ equals to 90 degrees minus theta. Here, the missing angle OB, angle OBC equals to 90 degrees minus theta. Okay. Likewise, we know that the sum of the angles in the right triangle, triangle AON, must be equal to 180 degrees. So which angles we have here? We have one angle that is equal to 90 degrees. We also have one angle that is equal to 90 degrees minus theta, and we have third angle that is equal to angle ON. In total, the sum of those three angles must be equal to 180 degrees. Ninety degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we're left only with minus theta plus angle OAN equals to 0. We'll add theta to this equation, and we'll get that the missing angle OAN equals to theta. Okay, so we found out that this angle equal to theta. So we actually found out that all the angles of triangle ON can go into all the angles in triangle BCQ. Why? Because both triangles have angle theta, both triangles have angle that is equal to 90 degrees minus theta, and both triangles have one angle that is right angle. Therefore, we can conclude from it that those two triangles are similar to each other. That is to say, we will conclude that the right triangle, triangle AON, this triangle is similar, this is the sign of similar, to the right triangle, triangle BCQ, according to angle similarity rule. And from the fact that those two triangles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that QC or QC over OA is equal to BC over NO. I repeat again, from the fact that those triangles can run to each other, we conclude that QC over OA equals to BC over NO. And what is the value of line segment QC. QC is equal to QO minus CO. So QC is equal to QO, that is R, minus QC, that we will define as A. So in conclusion, we found out that QC equals to R minus A. QC equals to R minus A. Here we defined QC as A, therefore all the other sides of square ABCO will be equal to A, because all the sides of a square are equal to each other. So, and we found out that QC equals to R minus A, so we can substitute QC in equation number 1 by R minus A. We'll do it now and we'll get it according to equation number 1. QC is R minus A over OA. OA equals to A. And it is equal to BC, that is also A, over NO. NO equals to R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. We will focus on the right triangle, triangle AON. In the right triangle, triangle AON, we know that here in this right triangle, that tangent theta is equal to R over A. I'll repeat again. In the right triangle, triangle AON, we know that tangent theta equals to R over A. And here, so therefore we can substitute R over A in equation number 1 by tangent theta. We'll do it now, and we get that according to equation number 1. But before that, we will split this expression to two expressions. R minus A over A equals to R over A minus A over A, that is minus 1, that is equal to A over R. So, we found out that according to equation number 1, R minus A, R over A minus 1 equals to A over R. But R over A equals to tangent theta, so we'll substitute R over A in equation number 1 by tangent theta. We'll do it now and we'll get that tangent theta minus 1 equals to A over R, but A over R equals to 1 over R over A. So now we can substitute R over A by tangent theta in equation number 1. We'll do it now and we'll get that according to equation number 1, tangent theta is equal, tangent theta minus 1 equals to 1 over tangent theta. Here we'll multiply equation number 1 by tangent theta, and we'll get that according to equation number 1, tangent theta times tangent theta is tangent square theta, minus 1 times tangent theta is minus tangent theta, that is equal to 1. Here we subtract 1 from equation number 1, and we get that according to equation number 1, tangent square theta minus tangent theta minus 1 equals to 0. So here we have a quadratic equation. The missing variable here is tangent theta, and actually the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of L according to, we find out the value of x according to the following formula for x. X equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. Okay? And in our specific quadratic equation, we know that the coefficient a equals to 1, the coefficient b equals to minus 1, and the coefficient c equals to also to minus 1, and the variable that we are looking for, that is to say x, is equal to tangent theta. So we'll put the data inside this equation for x in order to find out the value of tangent theta, because if x equals to tangent theta, so x that equals to tangent theta will be equal to minus b. B is equal to minus 1, so minus b is minus 1, that is plus 1, plus minus square root of b squared. B is minus 1, so b squared is minus 1 square root, it is 1, plus 4 times a is 1, times c is minus 1, so minus 1 times minus 4 is 4, over 2a, it is 2. So here we have two solutions that are possible for tangent theta. The first solution is tangent theta equals to 1 plus square root of 5 over 2. And the second solution for tangent theta is that tangent theta equals to 1 minus square root of 5 over 2, and we'll focus here. Tangent theta equals to 1 minus square root of 5 over 2 is a negative number, it is less than 0. So if we focus on the right angle triangle NMQ, we have here angle that is equal to 90 degrees minus theta. That is absolutely a positive angle, because it is 1 out of 3 angles in the right triangle, therefore it must be a positive angle. So we can write down that 90 degrees minus theta is greater than 0. We will add theta to this equation and we get that 90 degrees is greater than theta from one side. But from the other side, here we can see that angle theta is 1 out of 3 angles of a right triangle, therefore it is absolutely a positive angle, so it is greater than 0. So we actually found out that the range of numbers that tangent theta can be is from 0 to 90 degrees, And from 0 to 90 degrees, tangent theta is a positive number. Tangent theta is greater than 0. Between 0 to 90 degrees, tangent theta is greater than 0. Therefore, we have a contradiction here because tangent theta is a negative number. According to what we just right now found, we found out that tangent theta must be a positive number. So we have here a contradiction, so we'll cancel this solution and we're left only with the solution that tangent theta equals to 1 plus quarter 5 over 2. And we want to find out the value of tangent itself, the value of theta itself. So we will operate the inverse function of tangents on the result, that is 1 plus quarter 5 over 2, in order to find out the value of angle theta itself. So the inverse function, the inverse function of tangents, when we operate it on the result that is 1 plus quarter 5 over 2, is equal to, here it is equal to, check in the computer, 82.3 units. It is 58.28 degrees. It is equal to 58.28 degrees. So the answer to the question is that angle theta, the angle that we are looking for, is equal to 58.28 degrees. And that is the answer to the question, that this angle theta equals to 58.28 degrees. 58.28 degrees, about 58.3 degrees. That is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of tangent theta. Here we have a quarter circle, and inside this quarter circle we have square ABCO, and we also have angle AMB that is equal to 90 degrees, and we also have angle PQC that is equal to theta, and we want to find out the size of angle theta. So in order to find out the value of angle theta, we made a construction. We extended line segment MA, and also we extended line segment QO until they intersect with each other at point O, at point N, this point. Then we completed the quarter circle to a semicircle, and here we have the reference angle NMQ that is equal to 90 degrees. And we have also rule number 1, according to rule Number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So here we have peripheral angle NMQ that is equal to 90 degrees, therefore going to number 1, it must rest on the diameter, and angle NMQ rests on NQ. That is to say, according to rule number 1, NQ is the diameter of the semicircle. Okay, NQ is the diameter of the semicircle. Then, because of the fact that it is given as the question that this is a quarter circle, then QO must be equal to the radius of the quarter circle. So if we define the radius of the quarter circle as R, then we get that the radius that QO equals to the radius of the quarter circle that is actually equals to R. So QO equals to the radius that is R, and the diameter of any circle or quarter circle is twice as large as the radius, therefore it will be equal to 2 times the radius, 2R. So Qn equals to 2R. And what is the value of On? On equals to Qn minus Qc. So On equals to Qn minus Qc. Qn or NQ equals to 2R and QO equals to R. So 2R minus R equals to R. So we found out that On equals to R. And then we know that in the right triangle NMQ, the sum of the angles must be equal to 180 degrees. So which angles we have in triangle NMQ? We have here 90 degrees, we have here angle theta, and we have also angle MNQ. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle theta plus angle MNQ equals to 180 degrees minus 90 degrees, it is 90 degrees. We subtract the theta from this equation, and we got that the missing angle MNQ equals to 90 degrees. So this angle, the missing angle equals to angle MNQ equals to 90 degrees minus theta. Okay? Then we have already found out that NQ is the diameter of the semicircle. NQ is the diameter, must be a straight line. So we can find out that NQ must be a straight line, and we have rule number 2 that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if you focus on one side of a straight line at a central point, then the sum of the angles there must be equal to 180 degrees. So if you focus on the upper side of the straight line NQ at point O, then the sum of the angles on the upper side of the straight line NQ at point O must be equal to 180 degrees. So which angles we have at point O? We have here 90 degrees plus angle AON. In total, the sum of those two angles must be equal to 180 degrees. So 90 degrees plus the size of angle AON in total must be equal to 180 degrees. According to this rule number 2, we subtracted 90 degrees from this equation, and we got that the missing angle AON equals to 90 degrees. So this angle, the missing angle equals to 90 degrees. Likewise, if you focus on the upper side of the straight line NQ at point C, then the sum of the angles here must be equal to 180 degrees. Which angles we have here? We have here 90 degrees plus angle BCQ. In total, the sum of those two angles must be equal to 180 degrees. So at the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees according to rule number 2. So 90 degrees plus, at point C we have 90 degrees plus angle BCQ. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we got that the missing angle BCQ, this angle must be equal to 90 degrees. Okay? So we continue to focus on the right triangle BCQ. In this right triangle, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have here 90 degrees, we have here angle theta, and we have angle CBQ. In total, the sum of those two angles must be equal to 180 degrees. I will repeat again. 90 degrees. In triangle BCQ we have 90 degrees, we have angle theta, and the third angle is angle CBQ. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 90 degrees from this equation and we got that theta plus angle CBQ must be equal to 180 degrees minus 90 degrees, it is 90 degrees. We subtracted theta from this equation and we got that the missing angle CBQ equals to 90 degrees minus theta. The missing angle here equals to 90 degrees minus theta. We did the same process on the right triangle, triangle AON. In the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. Which angles we have at the right triangle, triangle AON? We have here 90 degrees, and we have here angle that is equal to 90 degrees minus theta. And the total, and we have also here angle OAN. In total, the sum of those three angles must be equal to 180 degrees. I repeat again, 90 degrees, the first angle, the second angle is 90 degrees minus theta, plus the third angle. In total, the sum of those three angles must be equal to 180 degrees. We have here 90 degrees plus 90 degrees is 180 degrees. So on both sides of the equation we have 180 degrees, so 180 degrees will get cancelled, and we left only with minus theta plus angle OAN must be equal, it is equal to 0. We added theta to this equation, and we found out that the missing angle OAN equals to theta. This is the missing angle that is equal to theta. Okay? So, we actually found out that all the angles in the right triangle CBQ can go into all the angles in the right triangle AON. Why? Both those two triangles have angle theta, both those two triangles have angle that is equal to 90 degrees minus theta, and both those two triangles have this angle that is equal to 90 degrees. Okay? So, therefore, we can conclude from it that those two right triangles are similar to each other. Okay? Because they have exactly the same angles. So we conclude that the right triangle, triangle AON is similar to the right triangle, triangle BCQ. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that QC over AO equals to BC over NO. I repeat again, according to equation number 1, we conclude that QC over OA equals to BC over NO. What is the value of QC? You can see from the drawing that QC or CQ equals to QO minus CO. QC equals to QO minus CO. So QC equals to QO, that is R, minus CO that we defined as A. So in conclusion, QC equals to R minus A, therefore we can substitute QC in equation number 1 by R minus A. We did it and we got that QC is equal to R minus A and OA equals to A. According to our definition, OA equals to A. And here BC also equals to A because of the fact that all the sides of a square are equal to each other, and ON equals to R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. Then we splitted this expression to two parts. R minus A over A equals to R over A minus A over A, that is minus 1. Okay? And okay, so the equation number 1 will be R over A minus 1 equals to A over 1 because equals to A over R because we splitted the expression R minus A over A to two parts. Then we focus on the right triangle, triangle AON. In this right triangle, we know that tangent theta equals to R over A. Tangent theta in the right triangle AON equals to r over a. Tangent theta equals to r over a. So we can substitute r over a in equation number 1 by tangent theta. We did it and we got that we have in equation number 1 r over a, so we substituted it by tangent theta, and we got that tangent theta minus 1 equals to 1, and a over r is 1 over r over a. Now we can substitute r over a by tangent theta. We did it, and we got that tangent theta minus 1 equals to 1 over r over a is tangent theta. We multiply the equation number 1 by tangent theta, and we got the tangent theta times tangent theta is tangent square theta. Tangent theta times minus 1 is minus tangent theta, that is equal to 1. We subtracted 1 from equation number 1, and we got that according to equation number 1, tangent square theta minus tangent theta minus 1 equals to 0. This is a quadratic equation. The missing variable here is tangent theta, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a is equal to 1, b is equal to minus 1, and c also equals to minus 1. And x equals to tangent theta. Tangent theta is the variable that we are looking for. So we put the data inside the equation for x and found out the value of the values of tangent theta. Tangent theta will be equal to minus b. B equals to minus 1, so minus b is minus 1, that is 1, plus minus square root of b squared minus 4 times ac. B is minus 1, so b squared is minus 1 squared, that is 1, minus 4 times a is 1, so minus 4 times a is 1 times c, that is minus 1. So we have in the equation minus 4 times 1 times minus 1, minus 4 times minus 1 is plus 4. So inside the brackets we have 1 plus 4, that is 5. So in conclusion we found out that tangent theta equals to 1 plus minus square root of 5 over 2. This is the first solution. And the second solution for tangent theta is that tangent theta equals to 1 minus square root of 5 over 2. That is a negative solution. But here we can see that angle 90 degrees minus theta is 1 out of 3 angles in the right triangle NMQ. Therefore it is absolutely a positive angle. So we can find out that this angle 90 degrees minus theta is greater than 0. We added theta to this equation and we got that theta is less than 90 degrees from one side, but here you can see that theta is 1 out of 3 angles of a right triangle, therefore it is absolutely a positive angle. So from the other side it is greater than 0. So angle theta is between 0 to 90 degrees, and in this range of angles, tangent theta itself is a positive number. So but we found out that tangent theta is negative, so we got a contradiction. We have a contradiction here. According to what we just right now found out, that tangent theta must be a positive number, but according to the second solution, tangent theta is a negative number. So this solution, we have a contradiction, so this solution is a correct solution. We cancel this solution and we left only with the solution that tangent theta equals to 1 plus square root of 5 over 2. So if tangent theta equals to 1 plus square root of 5 over 2, then we will operate the inverse function of tangents on the result, that is 1 plus square root of 5 over 2, and we will get the angle theta itself. Okay, so we provided the inverse function of tangents on the result, that is 1 plus square root of 5 over 2, and we found out that angle theta itself equals to 58.28 degrees. I will repeat again that the answer to the question is that angle theta equals to 58.28 degrees. Okay, thank you very much.